Welcome to Notes on Dilations. The objectives for these notes is to dilate a figure about the origin given a scale factor and to determine the scale factor of a dilation given a figure and its image. And so hopefully you recognize the term dilation. Your pupils get dilated when you go to the eye doctor. They make them bigger or larger depending on the exposure to light. And so we're going to mimic that on a coordinate plane. And officially, a dilation is a transformation that moves each point along a line that goes through the center of dilation and a preimage point. So if you take a look at the graph, you'll notice the center of dilation here is going to be the origin. The preimage is B, and then B prime winds up being along the same line that connects all 3 points. Looking at the origin, our center, with C and C prime, they're all on the same line. The origin D and D prime, origin A and A prime. So that should be a characteristic when you do your transformations with a dilation. And then specifically, we're talking about getting a bigger image or a smaller image. And the scale factor is what helps us to determine how that looks. And it's the ratio of the image length to the pre-image length. That's the multiplied distance that creates a dilated figure. So if you look in terms of a rule, we have that ordered pair x comma y goes to a new ordered pair where the k is multiplied towards the x and the y to make bigger coordinates or smaller coordinates depending on the transformation. If you look at the first example here, we are talking about enlarging a figure. And so it says, what are the coordinates of the image of ABCD after a dilation with center 0, 0 and scale factor 2? So if you notice in step 1, ABCD has coordinates written down that match the graph of ABCD. And then it says that you can find the image points by multiplying the coordinates by the scale factor. And so that's exactly what I'd like for you to fill into the notes. If A is at 2, negative 2, multiply each of those coordinates by 2, and you get what's highlighted here. A prime is 4, negative 4. B prime, similarly, is going to be 4, 2. If you multiply both the 2 and the 1 in the ordered pair for the preimage by 2, you get 4, 2. C prime, similarly, is 8, 0. And D prime is 8, negative 2. And if you look at the graph, we do have that 4, negative 4 matches with A prime, 4, 2 with B prime. D prime is at 8, 0, or 8, negative 2, I'm sorry, and C prime is at 8, 0. If you look at the bottom example, we're asked to dilate to reduce a figure. And if you look at the problem, it says, what are the coordinates of the image of PQRS after a dilation with center 0, 0 and a scale factor of 1/2? If you notice, the previous example had a scale factor of 2. This one has 1/2. And so the nature of the number 1/2 is small. That means we are going to get smaller coordinates. Looking at the preimage points for PQRS, if we multiply every set of x, y by 1/2, we will get the image points. So 6 times 1/2 or divided by 2 is 3, 10 divided by 2 is 5. And if you look at the graph, 3, 5 is where P prime is plotted. 10, 10 becomes 5, 5. 10, 6 becomes 5, 3, dividing each of those by 2. And so just keeping in mind that you are multiplying the scale factor by 1/2. This is a reduction. If you look at the graph, we do have that image is closer to the origin than the pre-image. Something I want to tie in, if you take a look at the top of our notes here, we did say that the scale factor is the ratio of the image to the pre-image length. And so just to toss that idea in here, if we want to compare the pre-image to the image in a fraction form, pick any of the points P, Q, R, S, and maybe we pick P. The pre-image is P, the image is P prime. And if I write the coordinates for each of these, P prime is at 3, 5 based on our math, and P is at 6, 10. And how to get the scale factor from here is to look at the x coordinates together or to look at the y coordinates and to look at them as a fraction in simplified fraction form. So 3 over 6, a lot of people might jump to saying this is equal to 2 when you simplify, but it's actually equal to 1/2. And same thing with 5 over 10. If you simplify 5 over 10, you can divide by 5. And so either way, we get that when we take the image to the pre-image, we get 1/2. And that corresponds to what we were given in the problem. The scale factor is equal to 1/2, so everything matches. If you turn your paper over, here's our summary page. When the scale factor is greater than 1, the dilation is an enlargement, if you'll fill that in right here. And when the scale factor is between 0 and 1, when it's a small decimal or fraction, then it will result in a reduction. And the graphs show that. In the first one, A moves further out from the origin, the center of dilation. And then in the second graph, we have that A comes closer to the center of dilation towards the origin. So we have two examples to try on our own to close out the notes. If you take a look at example 1 here, we are given a triangle DEF with a center of 0, 0, and asked to dilate that by a scale factor of 2. And so if we write down the coordinates first to D, E, and F from the graph, we get 0, 0, 0, 2, 0 for E, and 0, 2. Because the scale factor is 2, we are going to multiply each of the coordinates by 2. And so 0 multiplied by 2, 2 multiplied by 2, and that's really all we need to work with in order to get our images. And if we recall from our simple multiplication, 0 multiplied by 2 is just going to be 0. 2 multiplied by 2 is going to be 4, but the 0 stays the same. And then 0, 4 is where our image is going to be. Plotting these points, D is the same point as D prime. E is at 4, 0, or E prime I should say. And then 0, 4 is F prime. And if you draw in this triangle, it's the same shape but a different size, which is the whole point of a dilation. And then we have our image prime notation to indicate the image. If you take a look at example 2, now you are given actually a point in its image, and we're going to figure out what the scale factor is. So L is already graphed for us, that's at 3, 6. L prime is at 2, 4. And I would like for you to figure out what's the scale factor, finish graphing the image, and then what's the length of M prime, N prime. And just a note before we do some math with it, but the center is 0, 0, so every point should go through both the center, which is the origin, and the pre-image. And if it doesn't, then we've done something wrong with our graph. So if you take a look at our definition of scale factor from the previous page, we wrote that it's the ratio of the image to the pre-image. And so pick your L and L prime. L prime is the image, L is the pre-image. And so I'm going to set up the ratio as 2 over 4 and 3 over 6. Again, it is preferred that you show your ratio as a fraction when you're doing your scale factor and in simplest form. So between those two fractions, 2 over 3 and 4 over 6, 2 over 3 has the smaller numbers. And so I can say that the scale factor is in fact 2/3. This is a reduction. It's smaller than 1, bigger than 0. And then that should make sense because on the graph, L prime is closer to the center than L. And so I can use the scale factor to get M and N. M is at 3, 3, and N is at 6, 3. Just like in the first example to the left on the screen, we can go ahead and take each of the ordered pairs and multiply the coordinates by 2 over 3. So there is some fraction work, or if you can think about what would you do with your thirds, if you can break down a number into thirds and then get 2/3 of it, for example, that would also work. And so if I just do a little manipulation here, if I multiply 3 by 2/3, the scale factor, 6 by 2/3, and then I actually have 3 repeated quite a bit, you can write each of those coordinates as the number over 1 and then just multiply across. If you multiply across, you get M prime is 6 over 3, which is 2, and then that's going to be the same for the y coordinate. And N prime, 6 times 2 in the numerator is 12, 1 times 3 is 3, so that's going to be 4, and then another coordinate of 3, we get 2 for the prime. And so 2, 2 on your graph for M prime falls on that line that connects the center to the pre-image, and then N prime should be at 4, 2, which again is on that line that connects the center to the pre-image. And here is my image triangle. And then from here, I can say what's the length of MN prime. Well, if you look, it's the bottom of the triangle as it's drawn, so that's 2 units. I could have also taken MN as the length of a triangle, which I'll go ahead and highlight in red here. I could have taken that 3 units and multiplied that by 2/3, and I would have gotten the same length. It applies to both coordinates and length when you apply a scale factor. So either way, it'll work. And that's dilations for you.